Here I want to look at solving exponential equations by finding a common base. But first, let's take a look at a seemingly obvious rule, but will actually be of some real help here in just a few minutes. So this says for any positive number a, such that a is not equal to 1, we have a to the m is equal to a to the n if and only if m equals n. And your natural reaction to this, maybe, and rightly, would be that that's rather obvious, right? If we have a to the m, that would be equal to a to the m, right? That should make sense. But one of the really nice parts about this is that these are equal, assuming you can find a common base here. These are equal if and only if m and n are equal. So let's see how we can maybe use this in practice. So here we have 81 to the 4 minus 2x is equal to 9 to the negative 2x. Okay, so the first thing we should note is that 81 can be written as 9 squared. So really, this first example can be written as 9 squared to the 4 minus 2x, and that would be equal to 9 to the minus 2x. All right, so now, since we have a power raised to another power, we have to multiply them together. So we get 9 to the 2 times 4 minus 2x is equal to 9 to the minus 2x. So we have a common base. And therefore, we only have to consider the m and the n. So we now can look at this as 2 times 4 minus 2x is equal to negative 2x. And let's see if we can solve this for x. So if we distribute this 2, we'll get, looks like 8 minus 4x is equal to negative 2x. So we can add 4x to both sides. Okay. And we get 8 is equal to positive 2x. So we can divide both sides by 2. And we get that x must be equal to 8 over 2, which is equal to 4. Okay, so let's go ahead and plug this back into the part where we have the common base. So if we plug in x equals 4, we will have 9 to the 2 times 4 minus 2 times 4. That should be equal to 9 to the minus 2 times 4. All right, or we get 9 to the 2 times negative 4 is equal to 9 to the negative 2 times 4, or we get 9 to the negative 8 is equal to 9 to the negative 8, right? Which is obvious. Therefore, x is equal to 4 in this situation. Okay, let's take a look at this one. Here we have 64 is equal to 32 to the negative x plus 2. All right, well, let's go ahead and do ourselves a favor and write this as 64 to the first power is equal to 32 to the negative x plus 2. Okay, that's the first thing we should do. And now let's see. First of all, in this one we have to change both of them. Okay, we can't write 64 as 32 raised to the something. But one of the things that's really nice is each of these do have something in common. They both can be written as 2 raised to the something. 64 can be written as 2 to the 6 raised to the first, and 32 can be written as 2 to the 5th raised to the negative x plus 2. Okay, so now what we can do is we can multiply these out, these exponents. So we have, this will just be 2 to the 6th is equal to 2 to the 5 times negative x plus 2. All right, and now we can just consider 6. We can now just consider 6 is equal to 5 times negative x plus 2. Okay, So let's go ahead and distribute this 5 to the negative x and to the 2. So we'll have 6 is equal to negative 5x plus 10. And if we take 10 away from both sides, we get negative 4 is equal to negative 5x. We can divide by negative 5. Okay? And we get that x is equal to 4/5. All right, and what's nice about this is we can go ahead and plug in x equals 4/5 here. And if we use a calculator, if we raise 32 to the negative 4/5, negative 4/5 plus 2, my calculator, we will get 64. So there we go. So x is equal to 4/5. All right, let's do one more. Here we have 8 equals 4 to the x plus 1. So here, we can notice again that we can't write 8 as 4 raised to anything. So we should look for a common base that they both have. All right, so let's take a look at 2. That's really the only other option we would have here. So here we could write this as 2 to the third. 2 to the third is equal to 2 squared to the x plus 1. So 8 is 2 to the third, 4 is 2 squared. All right, and now we can write this as 2 to the third is equal to 2 to the 2 times x plus 1. And now we only have to consider 3 is equal to 2 times x plus 1. If we distribute this 2, we'll get 3 is equal to 2x plus 2. If we take 2 away from both sides, we'll get 2x is equal to 1. Dividing both sides by 2, we get x is equal to 1/2. And now let's double check that. So if we plug in x equals 1/2 for our equation here, we have 4 to the 1/2 plus 1 is equal to 4 to the 3/2. So if we plug that in, 4 to the 3 over 2, we will get 8. So there we go. That works out. So x is equal to 1/2. So yeah, these really aren't too bad. You just have to remember that you can oftentimes find a common base when solving these problems.